Putting aside the availability of fossil fuels, the politics of energy policies, or any other variables that affect the price of fuel, it is what it is. And I'm sure all of you have your own opinions. Our company's focus is how to generate more energy out of existing combustion engine technologies. To understand how we do this, we have to review and understand some of the basics. The first law of thermodynamics states that energy cannot be created or destroyed. However, energy can be converted into other forms. Therefore, energy equals heat plus work. Basic algebra tells us that if more heat is converted from energy, we're left with less work. But if less heat is converted from energy, we get more work out of the engine. However, the second law of thermodynamics states that heat out is always less than heat in if we also want to get some work out of the equation. In other words, if work is to be extracted, the combustion process itself is inefficient to begin with, before we experience the mechanical and parasitic losses from a propulsion system. For a combustion engine to work, it must have fuel, fire, and oxygen to convert energy from one form to another. It cannot produce energy from nothing. The amount of useful work obtained from a given amount of energy depends on the efficiency of the conversion, or in this case, the combustion process. Remember, the combustion process is not 100% efficient. Some of the energy stored in fuel is also wasted because of incomplete combustion. The inefficient combustion of fuel inside your engine leaves behind unburned or partially burned byproducts, such as carbon, nitrogen, oxygen, hydrocarbons, and sulfur. An engine converts fuel into energy by the following chemical process. The CXHY represent the fuel. For example, gasoline is C8H18. That's 8 parts carbon and 18 parts hydrogen. And diesel is C12H26. The CO2, H2O, CO, HC, and C on the right side of the arrow represent products that are released in the engine exhaust. The delta H represents the energy created from the thermodynamic process taking place inside an engine. There are no exothermic or energy-producing reactions that could yield more energy out of the CO2 or H2O, so we've grouped those components together in this equation. However, there are exothermic reactions that can extract additional energy from the second group, the CO, HC, and C. When FPC is introduced into the engine, it acts as a catalyst and lowers the activation energy needed to further break down the unburned products in these reactions. Specifically, when FPC is used, the following additional chemical processes take place in the engine. FPC increases your engine's output by generating additional delta H or energy as represented by these three equations. These delta H's add to the delta H produced by the engine's standard process to deliver more output energy from the engine. This extra energy can be used to either increase engine output power if the amount of fuel input is kept constant, or reduce the engine's fuel intake if the amount of output power is kept constant. What is FPC? FPC Fuel Performance Catalyst is a unique flame initiator that causes rapid ignition and enhanced combustion throughout the entire power stroke, increasing power output, reducing combustion time, and diminishing the products of incomplete combustion. An internal combustion engine will require less fuel to do the same amount of work if the fuel can be made to burn more efficiently. Molecules of ferrous picrate act as flame initiators within the fuel at the instant of ignition. Because of this, the flame in your engine's combustion chamber isn't propagating only from top to bottom. It's also propagating from all of the FPC molecules in the fuel. Here you can see a unique explosion phenomenon in fuel treated with FPC. With faster flame propagation in the combustion chamber, and a reduction in the time required to burn the fuel, more of the fuel in the chamber will be burned on each stroke, and less will be wasted in the exhaust. The result is more fuel being converted to motive power. Remember, the efficiency of a combustion engine is work out divided by heat in. On the diagram of a thermodynamic cycle, the y-axis shows pressure, and x-axis shows volume. The area enclosed by the loop is the work done by the process. Sensors inside laboratory engines have shown that FPC changes the pressure cycle inside the combustion chamber. The important feature of this plot is that the area under the curve for FPC treated fuel is larger than the area under the untreated curve, meaning the average pressure is greater inside the chamber. Since the piston is receiving more force driving it down faster, more output power will be delivered to the crankshaft, resulting in efficiency improvements. The basic principles behind the benefits and catalytic effects of FPC are easy to understand. Today's engines leave some amount of fuel unburned on each piston stroke. FPC makes it easier for your engine to burn more of the fuel in the cylinder. Since more of the fuel is being burned, more power is being generated. Since less of the fuel is being wasted, you will have fewer emissions. The University of Western Australia has successfully captured imagery of diesel fuel burned with and without FPC in a furnace. The time-lapsed images taken by UWA support the hypothesis that FPC acts as a flame propagator in the combustion chamber. The top picture displays a sequence of images showing the burning of untreated diesel fuel. The bottom picture displays a sequence of images showing the burning of diesel fuel treated with FPC. The time between the frames is 25 milliseconds. FPC is a catalyst that makes fuel burn more efficiently. Many fuel additives claim to be catalysts, but in scientific terms, they are not true catalysts. FPC increases fuel efficiency even for brand new engines and continues to provide benefits as long as you continue to use it. Other fuel additives are just solvent-based products that clean the dirt in engines. FPC also contains solvents that keep your engine clean and more efficient over time. However, it is our patented catalyst, ferrous picrate, contained in FPC that increases efficiency in any engine, even in a new, perfectly clean engine. Increasing efficiency on a new engine is something our competition just can't do. The RP503 says it all, and FPC has passed it twice. What is the RP503? In 1980, the Association of American Railroads adopted Recommended Practice 503 to scientifically and thoroughly test the effectiveness of fuel additives on new and in-service locomotive engines. Of the many procedures by which fuel additives are tested, the specifications set by the AAR RP503 are the most stringent. The RP503 procedure involves a multi-phase test sequence by which treated fuel specifications are exactly analyzed, then combustion products and engine wear effects are carefully examined, and finally fuel consumption changes are precisely measured in an as-new EMD 645 E3B diesel engine. The RP503 test on FPC was conducted at the internationally renowned Southwest Research Institute in Texas at a cost of approximately $250,000. For the first RP503 test, FPC was tested on a brand new laboratory engine. For the second RP503 test, FPC was tested on an in-service locomotive engine. The results of the RP503 tests for FPC show a carefully measured 1.74% reduction in fuel consumption as a result of treating fuel with the FPC catalyst, which Southwest Research Institute noted was significant and with 95% confidence. Test results showed no detectable adverse wear or deposits on engine components, no measured increase in undesirable emissions, no alteration to fuel specifications. From the start of fuel treatment to the point of new level engine performance, a transition or conditioning period of 130 hours was established. How significant is a 1.74% reduction in fuel consumption? To put that figure in some sort of context, the Union Pacific in April 2006, through a number of energy conservation initiatives, reported it shaved 2% off its diesel fuel consumption, resulting in saving nearly $7 million. Railway Age magazine reported the Montana Rail Link system ordered FPC after testing resulted in a fuel consumption reduction average of 7.7% and a smoke reduction averaging 26.9%. FPC is a ferrous pick rate-based fuel catalyst. The benefits of using ferrous pick rate in fuels have been well known for decades. The first patents on ferrous pick rate date back to 1944. FPC has never damaged an engine of any type or size in any way. FPC is based on real science. Dating back to the end of World War II, it has been tested close to 2,600 times. No other fuel additive has been tested as much or proven as effective as FPC. These reports are available in our test library at www.fuelchemenergy.com or www.fpc1.com. Hundreds of thousands of dollars have been spent developing and testing FPC. These beneficial results have been confirmed utilizing rigorous EPA, SAE, the Association of American Railroads, test procedures for fuel additives. In addition to hundreds of field tests, FPC has been tested at independent laboratories and universities around the world, including the United States, Canada, Australia, Italy, and India. Throughout the United States and several other countries, these tests involved hundreds of trucking, busing, mining, construction fleets, ships, tugboats, locomotives, and open flame applications. Tens of billions of dollars worth of equipment have been treated with FPC. Using FPC will not void the warranty on your equipment and will not alter fuel specifications in any way. FPC is listed as a non-flammable liquid for shipping within North America and does not contain chemicals that would make your fuel hazardous. FPC has been tested on the following engines. It has been proven not to harm engine components. In fact, FPC does just the opposite by improving combustion to the point where abrasive hard carbon buildup is virtually eliminated. As a result, engine wear related to hard carbon buildup on rings, injectors, valves, and liners is reduced. Further, oil contaminants are reduced, cutting down on the wear to lower engine components. We don't just make claims. We publish our results, and more importantly, we guarantee our results. The manufacturer of FPC warrants that the use of FPC according to manufacturer's directions will increase the engine's efficient use of fuel so that the net savings realized will exceed the purchase price of the FPC. Should the use of FPC fail to affect such economic savings, the manufacturer shall refund to the buyer the difference between the savings in fuel costs and the cost of FPC, but in any event not to exceed the total purchase price of FPC. The manufacturer further warrants that FPC will not, when used according to the directions, damage in any way or shorten the life of internal combustion engines. FPC is no snake oil. For every $1 you invest in FPC, you can save $2 to $4 in fuel costs. The reduction in fuel consumption and the money you save using FPC is only one of many benefits, including improved performance and power output. Improved horsepower. Since FPC changes the pressure cycle inside the combustion chamber, the piston is being driven down faster, resulting in more output power delivered to the crankshaft. With FPC, the accelerated combustion process allows more of the fuel in the combustion chamber to be burned on each stroke, therefore reducing exhaust emissions. FPC reduces carbon deposits on the injectors, piston face, rings, and valves, thereby extending injector life and reducing engine wear dramatically. You'll have less maintenance and downtime. Engine adjustments and overhauls are decreased. The engine life is increased, fuel filters last longer, and oil change intervals are extended. Exhaust gas analysis tests have shown that FPC reduces both the particle size and the quantity of particulate matter. Fewer and smaller carbon particles result in less wear to metallic engine components. Oil analysis on heavy-duty diesel engines conducted over an extended period of time have shown a substantial reduction in oil contaminants when using fuel treated with FPC. There are 2 FPC production plants, in Western Australia, and the other is in South Point, Ohio. Our operations are all computer controlled. Large batches are blended, bottled, labeled, and boxed mechanically. Samples from every batch are tested in our chemistry laboratory using diode array spectrophotometers to ensure quality control. Our South Point production plant currently has the capacity to treat 12 million gallons of fuel each and every day. That's over 3 billion gallons of fuel each year. The underlying science is real, and the findings are supported by almost 2,600 published tests. Tens of billions of dollars worth of equipment have already been treated with FPC and has never damaged an engine of any type or size in any way. Using FPC will not void the warranty on your equipment. To fuel the future, we need to start today. The best place to start is with FPC.